aerial sugarcane fields. Across thousands of sunlit acres, sugar begins its life not in a factory, but in living fields. Every tall green stalk is a biological storage vessel built by months of light, soil chemistry, and controlled irrigation. This is raw energy, waiting to be refined. Modern harvesting is a science of precision. Mechanical cutters separate each cane cleanly from the soil, preserving internal sugar content and minimizing structural damage. Transport to factory. At the edge of the field, mechanical loaders take control, lifting full-length sugarcane with calibrated force, preserving stalk integrity while preparing it for transport. Loads are distributed to prevent crushing and moisture loss. Because sugar does not wait. The moment a cane is cut, its internal chemistry begins to change. Transport speed becomes yield. Agriculture officially becomes industry. From field to facility, time becomes a variable. The faster the transfer, the greater the yield. Every minute is chemistry. Every delay is loss. Washing and preparation. Before extraction begins, purification comes first. High-volume washing systems remove soil, fibers, and surface contaminants, ensuring that only clean organic structure enters the process line. Crushing and juice extraction. Inside the mill hall, pressure becomes the primary tool. Steel rollers collapse each stalk's internal structure, releasing raw sugarcane juice. pH testing and quality control. This liquid is not yet sugar. It is a chemical environment. Its acidity, mineral content, and organic load must be measured precisely before refinement can begin. Heating and chemical balancing. Temperature now becomes an instrument. At controlled heat levels, acids are neutralized, enzymes deactivated. As the solution settles, gravity performs its own filtration. Impurities rise, heavier compounds separate. What remains is liquor clear, calibrated, and chemically aligned for crystallization. Mixing white powder, calcium hydroxide, into juice. Refinement begins with chemistry. At this stage, the raw juice is still unstable, rich in natural acids and suspended compounds. measured calcium hydroxide is introduced with absolute precision. As the powder dissolves, invisible reactions begin. Testing the thick brown juice before crystallization. The liquid has now changed. Color deepens, density increases. Vacuum pan crystallization. Inside the vacuum pan, physics takes over. Under reduced pressure, water leaves the solution, and sugar molecules begin assembling into solid form, not randomly, structurally. Crystal growth monitoring. Testing the white thick liquid after heating. The liquid is ready to become solid. Centrifugation and separation. Centrifugal force completes the transformation. Industrial drying. Liquids are expelled, crystals remain. What exits this system is no longer syrup. It is solid sugar. Drying stabilizes the product. Moisture is removed. Surface tension is balanced. Flow properties are engineered. The crystal becomes shelf-stable. Macrocrystal texture. At microscopic scale, sugar is architecture. Each grain a geometric structure. Automated packaging, sachets and bags. Production becomes logistics. Automated systems form, fill, seal, and release thousands of units per hour, each one traceable, weighed, and mechanically identical. Industrial bag filling. From small retail sachets to 50-kilogram industrial sacks, every package is a calibrated container, designed to protect crystal structure and prevent contamination. Warehouse storage. Storage is not an endpoint. It is a holding phase inside a global distribution machine. Logistics and global movement. From field biology to molecular engineering, from raw stalk to crystalline form, this is not simply sugar. This is agriculture refined into precision.